Okay, so after looking over your short notes on impulse, we're going to look at an example here. Now I'm just going to write the formula at the top of the page so that we know what we're working with here. And so impulse has a very strange symbol in that it is J, I don't know where that actually comes from, is equal times to the force times the time that that force is being applied. So a very sort of different formula here. So let's read through the example and see where we're at. So a 1,000 kilogram car accelerates from 80 kilometers per hour to 100 kilometers per hour in 10 seconds. What impulse is experienced? So we're going to start this as we usually do by recording what we know. So I'm given the mass. So I will state that the mass is equal to 1,000 kilograms. I am given the initial speed and the final speed. So I'm going to write down in V1, sorry, my hand is in the way, is equal to 80 kilometers per hour, and V2 is equal to 100 kilometers per hour. Now, hopefully you can notice or be aware of the fact that these are in kilometers per hour, and in physics, we do not use kilometers per hour, so we need to convert those to meters per second. And I just realized again I have a calculator problem. So sorry, I'll just bring that up here really quick. I'll spend less time getting, okay. So the conversion to convert this to meters per second is to divide by 3.6. So I need to divide both of those by 3.6. which I'll just put in my online calculator here because that's what I have in front of me. 80. Okay, I thought I had my number locked, but forget it. I'll just go 80 divided by 3.6, which gives me 22.222, which I'm just going to write down as 22.2. And then I will do 100 divided by 3.6, which is 27 point, I'll round that to 27.8. Okay, so 27.8. And these are now meters per second. We're also given that time is equal to 10 seconds. Okay. So if we look at our formula again here, that impulse, our crazy J here, is equal to force times time, I clearly do not have that information given to me here. I have time, but I do not have force. So that then gives me direction. So that means I need to first calculate force. So I'm going to write down that formula. F is equal to ma. I do have my mass, but I do not have my acceleration. So that tells me that that is where I need to start. And looking at what I have here, I'm going to choose to write down that A is equal to my change in speed over my change in time. I'm going to choose this particular version. As you remember, we know lots of different ways to calculate acceleration, but this one will be straightforward. So change in just means the difference between. So I'm going to have 27.8 minus 22.2 divided by 10 is equal to, gosh, I'm having some brain moments here, 7.6. There we go, I can do that. 7.6 divided by 10, which gives me 0.76 meters per second squared. And I know my big red hand is all over the blocking things. I apologize. I was coloring some things earlier. Okay, so now I know my acceleration. I can go back up here to my force one. So force is equal to ma. Well, I know from my givens over here, my mass is 1,000 kilograms. So is equal to 1,000 times my acceleration that I just calculated. I can do that calculation in my head, thankfully. 1, 2, 3, that gives me 760, and our units for force are newtons. Okay, so now I went back up and did this one. Now it looks like I can come up and actually finally calculate my impulse. So I have J is equal to Ft. I have 760 newtons times, if we look over here, 10 seconds. So I have 10 seconds, which gives me 7,600. Now, impulse are Newton seconds. So these were newtons, these were seconds, and so this becomes our unit. So we have this J is equal to 7,600 Newton seconds. And now you'll be able to do the assignment.